Hi there, this video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2023. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 18 to 22, which account for 21 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18. The grid below shows triangle A and triangle B. Question A. Describe fully the single transformation that maps triangle A onto triangle B. So from A to B. Okay, so the first thing I can say here, it's not an enlargement because the shape hasn't changed size. It's not a translation because if it was a translation, then the shape would be exactly the same orientation as A. It would have just moved to the side or up or down. So this is either a reflection or a rotation. Now this is a rotation because you can quite clearly see that it's the shape itself, it's just changed orientation, it's turned around a little bit. So the first thing I'm going to write is rotation. Okay, and then what I'm going to say is this point here matches this point, and this point here matches this point. So actually, it's turned 90 degrees. So if we've gone from here, we've turned 90 degrees clockwise. We now just need to say what the centre of rotation is, so we need a coordinate, and I'm going to use tracing paper to help me with that, guys. Okay, so I'm going to draw shape A. Now remember from the previous videos that I've done, there should be tracing paper in your maths pack on your exam desk. If there isn't, stick your hand up, ask for some, they will have it, and you are entitled to use it. I'm going to use a different pencil because this probably won't rotate very well. Okay, so I know that it's moved 90 degrees in this direction, so I'm just going to pick a point. So let's imagine it was rotated around this point. So if I move that triangle, so it's not quite made it into the right place. I'm too low, I'm too high, and I'm not far enough across that way. Okay, so let's try here. 1 0. Sorry, I can't even do coordinates today, it seems. Okay, so this one is getting lower, it's getting closer. All right, let's shift across a little bit more. So we're going to the origin here. So put it on nice and tight. Ah, look at that, it matches. So that was on the origin. So the centre of rotation is coordinate 0, 0. Part B, translate triangle A using the vector -3, 2, and then label it C. So we're working with triangle A here and we're translating it. So we're not rotating it or anything, we're just moving it according to what this vector tells us. So that -3, so on the top we move left or right. If it's a negative, we move left. So we're going to go 3 places to the left. So we go 1, 2, 3, okay? The bottom is up and down. Negative would be down, positive would be up. So we're going 3 places to the left, 2 places up. So we're going to take each point. We're going to go 1, 2, 3 to the left, 1, 2 up. 1, 2, 3 to the left, 1, 2 up. 1, 2, 3 to the left, 1, 2 up. And then we're going to draw that shape. And don't forget it says to label it C. So let's label it C. Question 19. Shortbread biscuits are made from flour, butter and sugar. Their masses are in the ratio 4 to 3 to 2 respectively. So flour, butter, sugar, 4 to 3 to 2. I always make little notes like that in the ratio to make sure I remember which section of the ratio relates to what. Part A, what fraction of a shortbread biscuit is made up of sugar? So for a fraction, we need a total number of parts. So the total number of parts for our ratio is going to be 4 plus 3 plus 2, which is 9. We're interested in the parts that are sugar. Well, this is sugar here, so it's 2 of those 9 parts. Part B, 1,400 grams of flour is used to make a batch of shortbread biscuits. How many grams of butter is used for this batch of shortbread biscuits? So we're going to use this ratio from here. So flour, butter, sugar, and it's a ratio of 4 to 3 to 2, okay? So it tells us that it's 1,400 grams of flour. They want us to know how many grams of butter. So we're interested in what this part of the ratio would be. Now remember, when we're working with ratios, we scale up or down, we multiply or divide. So I'm going to figure out what I need to do to this ratio to get here. So I'm going to do 1,400 divided by 4, which is 350. So what I've done is I've multiplied by 350. So to find the amount of butter, I'm going to do 3 multiplied by 350, which is 1,050. So it's 1,050 grams of butter. Question 20. Lucy bought a car 9 years ago for £12,250. The car depreciated in value by 18% in the first year. In each of the following years, her car depreciated by 15% of its previous year's value. By how much has the car decreased in value in the last 9 years? So we've got a couple of steps here. We've got how much it depreciated in the first year, and then how much value it lost in the remaining years. Okay, so let's start with the first year. So we had a starting value of 12,250. It depreciated by 18%. So it started at 100% of its value and it depreciated by 18%. So that is 82%. Now 82%, if I divide that by 100 as a decimal multiplier, is 0.82. Going to work with decimal multipliers because I've got a calculator, so I might as well. So I'm going to multiply by 0.82. So 12,250 multiplied by 0.82. So at the end of the first year, the value of the car was £10,045. Okay, for the remaining years, so from 9 years, so for the remaining 8 years, it depreciated by 15% of its previous year's value. So depreciating by 15%, so 100% its cost at that time, take away 15% is 85%. 85%, if we divide that by 100, is 0.85 as a decimal multiplier. So we've got the value at the end of the first year multiplied by 0.85, but this time it's compound depreciation, okay, works the same as compound interest. This is happening for the remaining years. This was the first year, so we've got another 8 years. So we have to raise that to the power of 8. So 10,045 times 0.85 to the power of 8, which is £2,737.17. So that's how much the car's worth after 9 years. We want to know by how much it's decreased in value. So we want to know the difference from what it was to start off with and what it's worth after the 9 years. So 12,250 subtract its value after 9 years. So it's gone down in value by £9,512.83. Question 21. Regan caught 70 fish on a fishing trip. He measured the length of each of the fish in centimetres. The table shows his results. So we've got the range of lengths, the number of fish that fell within those ranges. Part A, calculate an estimate for the mean length of the fish. Okay, so we need to add some columns in here, guys. So we need our midpoint column. And then we're going to do our midpoint multiplied by our frequencies. So our midpoint is halfway between these two values. So add them together, divide it by 2. Okay, add them together, divide it by 2. and then I know the rest of them, but you could just add them together and divide it by 2 if you want to. Make sure you write your decimal points clear here, so when you do some calculations later, you don't forget that they were decimals. That's what some people do. And then that's 82.5. So now we're going to multiply the midpoint by the frequency. So we've got 62.5 times 19. So that's 1187.5. 67.5 times 17. 1147.5. 72.5 times 23, 1667.5, 77.5 times 10, and then 82.5 times 1 is just 82.5. So now we need to total those up, guys. So we've got a new frequency midpoint total. So 0.5 plus so that's 4,860. So now to estimate the mean, we do 4,860 divided by the total number of fish, which they very kindly told us at the start is 70. So it's the total divided by how many we have, which is 69.42857,143. You can round it if you want to, but it doesn't ask you to. So let's just say 69.4 centimetres, because we were working in centimetres. Okay, part B. Regan thinks that the median length of fish is in the group 70 to 75. Is Regan correct? Give the reason for your answer. Okay, we're not ticking a box yet. We're going to find out what the median length is and decide if he's correct. So to find the median, we have 70 fish in total. The median is the middle point, but it works slightly different with tables, okay? So we're going to divide the total number of points by 2, which is 35. So then we're going to do a cumulative total here, guys, to find out where that 35th fish would be. Okay, so we're going to start with 19 plus 17. So 19 plus 17 is 36. So once you go past 19, from 20 to 36, fishies are in here. Okay, well, we're interested in the 35th fish, so it's got to be in this group here. So he's wrong, because the median is, and then write the correct median group. So 65 is less than or equal to L is less than or equal to 70. Question 22. Jan has a large piece of card. The card has width 60 centimetres and length 96 centimetres. So this is the card here. Width 60, length 96. She uses a machine to cut identical circles out of the card, and each circle has a radius of 6 centimetres. So these are the circles she cuts out. Diagram not drawn to scale, so we can't just measure anything directly from it. Jan has cut 5 circles, as shown in the diagram above. She continues in this way to cut as many circles as possible from the card. Part A, what is the maximum number of circles Jan can cut out of the card? Okay, so let's think about these circles. The radius is 6, so all the way across the diameter must be 12 because it's double. So each of these circles has a diameter of 12. And it would work the same way down this way as well, obviously. So what we can do is we can do 96 divided by 12. Which is 8. So we would fit 8 circles along. But then we can do 60. So that's the width. Divided by 12. Which is 5. So we'd have 8 circles along and 5 circles down. So the maximum number of circles would be 8 times 5, which is 40. Part B. Jan cuts out the maximum number of circles from the card. What area of the card is left over? Okay, so if she cuts out 40 circles maximum, okay, she's going to cut out 40 of these circles. So 40 times by pi times 6 squared. Pi times radius squared is the formula for a circle. So she would cut 40 lots of that out. So let's work out what that would be. 40 times pi times 6 squared. I'm going to leave it in terms of pi so I don't have to type in a load of decimals later. Okay, so she's going to cut that area of circles out of this rectangle. So we need to find out what the total value of the rectangle is. So we're going to do 96 times 60. So that's 5,760. So that's the total area. That's the area she cuts out. We're interested in what's left. So we want the difference between those. So we're going to subtract them from each other. So 5,760 subtract 1,440 pi. So 5,760 subtract 1,440 pi is 1,236.106579. It doesn't ask us to round it, but I'm going to put 1236.1 centimetres squared on my answer line.